Okay, so with this question here, we're being asked how many six-digit even numbers are there that are less than 300,000 with no repetition of digits. Okay, so if it's six digits, that means that it's at least going to be 100,000. Um, but less than 300,000 means that it's going to be 299,000 or less. So if you think about it, there's two possible scenarios here. It's going to start with a 2 or it's going to start with a 1. So in both those cases, the first number is spoken for. Now let's take a look at our first row here. Starts with a 2, our first number spoken for. Now remember, if it's going to end in an even number, that means that that last digit there has to be 0, 2, 4, 6, or 8, which means we have 5 options. Same with here. 0, 2, 4, 6, or 8. That's what an even number is. 100,002, 100,004, 100,006, 100,008. I think you get the idea. Notice how they all end in a even number. So again, there's 5 even digits. Now, here's the reason that I split this into two groups, or two cases. Is that in the first case, we start with a 2, which means because there's no repetition of digits, we've used up one of our even digits. So we only have 4 options left. Now we've used up our first option, or we've used up two numbers here, the first number and the last number. There's 10 total digits, so 10 minus 2, that's 8 left. Then we have 7 left, then we have 6 left, then we have 5 left. Now let's look at the second case here, which is that it starts with a 1. Okay, so that means here we have 5 options left. We don't have to subtract any because 1 is not an even number. So we're saying that this last number here can be 0, 2, 4, 6, or 8. Again, this was a 4 because we spoke for that first number, and we said it's a 2, so we didn't have the option to go 2 here. So this number here could have been 0, 4, 6, or 8, just 4 options. Here, it could be 0, 2, 4, 6, 8. Okay, so we've used up 2. So we're looking at this case here. We've used up 2 of our 10 digits. So again, we have 8 left, then we have 7 left, then we have 6 left, then we have 5 left. So that gives us 1 times 8 times 7 times 6 times 5 times 4 equals 6,720. And 1 times 8 times 7 times 6 times 5 times 5, it's the second case, equals 8,400. We add those two up, and we get 15,120. Now, remember, these two items are mutually exclusive. That is, that none of these scenarios here can happen at the same time as these scenarios here. So we don't have to worry about subtracting any overlap. If that were the case, we'd have to subtract, but we can't start with a 2 and start with a 1. So we don't have to worry about any overlap. We can just directly add these two numbers and we derive our final answer. So hopefully this makes some sense. If not, you can ask questions in this thread. Now, the one thing that I really ask and beg of you guys is that if you have questions to ask in this thread, be specific about where I'm losing you. Because it's very hard for me to be able to answer questions if you're just saying I don't get it, because I don't know how to work with that. So just try to let me know where I'm losing you and at what step on the process. Now that I've said that, keep in mind this is actually one of the hardest questions you're going to encounter in this entire course. So if you're able to comprehend what I just did, give yourself a pat on the back because that's pretty good. If not, there's a chance you might want to walk away from this for a day or two and then maybe just think about it a little and after a couple of days maybe come back, rewatch this video, and it might actually click. But that first time you see this, you might be very confused. So that's okay. This is a pretty hard question. You will get there. You've just got to kind of keep thinking about it, and eventually this is going to clue in. Um, a question that I've gotten from students before when I've worked through this problem is they said to me, well, this second case, that's an odd number. Now remember, this doesn't represent a number that meets that criteria in the sense that 187,655. It's not that. This is just figuring out the number of even numbers that start with 1. So there's 8,400 numbers that begin with 1, so that are in the 100,000s that end in an even number. There's 8,400 of them. Conversely, there are 6720 numbers that begin with even digit even digit numbers in the 200,000s with no repeated digits. And I forgot to say that during this case here. There's 8,400 even numbers in the 100,000s with no repeated digits. If this question didn't have the repeated digits, it'd be a much easier question to answer. You could actually go about it the same way, except this here, both these would be fives, and all these digits here would be tens. Sorry, you guys can't see that, but my mouse cursor. Those two digits would be fives, and all these digits here would be tens, and then you'd add it up. Or you could just do one column and have this first number here be 2, and then all tens, and then a 5, which would work out to, like, I don't know, 100,000 or something. Or 200,000, or no, 100,000. So hopefully that makes some sense. If not, let me know and I'll do what I can to help. But again, please try to be specific if you have questions about this. All right.